Okie dokie. All right. Good evening, y'all. Let me get a mic check, make sure everything sounds good. Looks like it's functioning on my end. I got the screen of doom going here. Hey, Jonathan, Krista, Corbin, Deborah, Keith, TF, David. Thank you all for being here. Sorry I'm a little bit late. I am up here at Hood Base in Chicago. Was having dinner with my father. It went a little bit later. You know, that happens sometimes. So, apologize for those of you who have been sitting here waiting, but thank you. Thank you all for tuning in. We'll talk about tomorrow. Hope you're all having a good evening here. Of course, me being a weather person, you know, I'm having dinner and I'm talking to my dad, and I've got one eye like this, you know, looking at the phone, looking at the data. Right off the bat, what I've noticed is some pretty dramatic changes with the 0Z guidance. I was surprised to see the runs come in the way they did. So, you know, if you're a storm lover, it's really not the trend that you want to see. If you're a storm chaser like myself, if you're somebody who doesn't want the storms to happen, then maybe this trend is your friend. So we'll kind of get into that here. I'll just jump right in. You know, this of course is the risk area for tomorrow. This is the latest day 2. I'm sure we've all seen this right now. Large football shaped area. Southern Lower Michigan, Central Illinois, Northern Indiana. It says I do not have enough. Is this just YouTube being picky here? YouTube's telling me I don't have enough streaming data to keep this going, so I don't know. It looks good on my end, so if it's not working, just let me know. YouTube wants you to broadcast these things in like 8K, but let's be real here. Wi-Fi always isn't that good, so I'm going to keep it rolling. If it fails at any time, I'm sure y'all will let me know. Hopefully it stays running good. But anyway, here is the risk area for tomorrow. The new day 1 from the SPC will be out in an hour or so. Actually, not an hour, by about midnight. You know, cities like St. Louis, Chicago, Peoria, Springfield, Champaign, Effingham, Indianapolis. You know, you've got Fort Wayne and Grand Rapids and Lansing, Michigan. Even down here towards Coldwater, Michigan, places like that. So, you know, generally a slight risk in place for portions of the Midwest. I am going to move this over here so I can keep an eye on the signal, which looks good on my end. I don't know why YouTube is screaming at me. Hopefully it's just YouTube being picky, but that is very distracting. So let's just jump right in and look at some of the models here. So, you know, we're all waiting for the 0Z data to come out, right? So I'll just go right ahead, look at the 0Z HRRR. This is the 18Z run, so let's jump on over to the 0Z here. And, you know, of course, the first thing we all want to look at is the simulated reflectivity. That's the easiest, simplest way to see what may happen tomorrow. So we open our 0Z run, and what do we see? Stair stepping through some of this tomorrow. You know, suddenly what happened to all of the big storms that it was showing here? Northern Indiana, Central Illinois, some of these runs had some big storms in this region here. So now here comes the 0Z HRRR, you know, with kind of the upset here, showing some convection here across north central Illinois, the I-39 corridor. Not really doing much of it. A little cluster here along the Ohio River, and this is well after dark. This is like midnight here. So very little in the way of daytime initiation. So this was a very dramatic, different run than what we've seen from earlier in the day. Here's the 18Z run by comparison. Give that a... My scroller moves faster than it loads here. You know, compare that with the 12Z run, and you see much more of a bullish signal. from this morning's 12Z run here. So what happened? What is the difference? Maybe it's just an off run of this particular model. But then when we jump over to our other favorite convection allowing model, let's take a look at the 3 kilometer NAM. We just give that a second to load here. Yeah, my internet here must be running a little slow because I'm scrolling faster. But notice the 3 kilometer NAM kind of does the same thing. Little cluster of storms there in far north central Illinois, from near the Quad Cities, Davenport, the I-39 corridor here. Just a small little cluster of thunderstorms across northern Illinois. We don't see those big isolated potential supercell storms that we saw on this morning's run here. So we'll take a look at some of the model data, see what we can decipher, and see if we can pick apart just how this is going to play out. So let's go back to the 0Z HRRR and see what kind of environment that this thing is showing. And I'll draw and point out some things. We've talked about how this is somewhat of an interesting setup here that features something that we typically don't see in the Midwest, in the Great Lakes area, and that is a dry line, more pronounced on the HRRR here. So I'm going to pause this that is 0Z, so 6 p.m. Tomorrow here, and we'll draw some features. Okay, so the dry line is this area of dew point depression that we see right in this area here. So we've got a dry line. This is an unusual thing to see in the Midwest. And the gist of the dry lines is if you take, this is the United States. Okay, a little bit of emphasis on Florida there. The dry line is a prevalent feature in the central and southern plains because you have the desert air in the southwest that moves into the plains. That's what sets up that dry line boundary. It's hard to get the dry lines further east because you have the Gulf of Mexico down here where your moisture comes up. So often the air gets more moist the further east you go. So as the dry lines push further east, they encounter that moist air coming up off the Gulf, and they kind of mix out or they become diffuse and that sort of nature. So it's a little tough to get these dry lines further east, and that's some quick dry line 101 there. But we do have a dry line in place tomorrow. So very interesting feature there. Our primary cold front is draped across like this. Hopefully that's somewhat easy to see. Maybe if I do it darker blue, it'll show up a little bit better. So we have our cold front over there. And then, of course, we have a warm front that's going to be located something in like this. The warm fronts, they get hung up here on Lake Michigan, which, of course, is another wild card for the setup here. But this is somewhat of our surface pattern in play tomorrow. So when we look at where the HRRR is firing these storms here, the big change with the 0Z guidance is that it is no longer firing any storms in that dry line, quote unquote, that dry line warm sector here, except for maybe far across the south. But by then the cold front takes over. So what we were seeing in some of these earlier model depictions were the potential for storms to form in this region here ahead of that dryline bulge. This is something that happens a lot in the central and southern plains. That's a known target area that storm chasers like myself like to look for. We look for the dryline bulge. That is the area where your forcing is maximized. Things come together just a little bit better there. And that's what we were seeing as part of the signal for tomorrow. But now on this 0Z guidance from the NAM, the HRRR, even the RRFS no longer has storms in the dryline environment. That's over there on Pivotal. I can't see that here on COD. But that convection allowing model didn't have any more dryline storms either. So that's kind of an interesting trend there, and doesn't necessarily mean that it's right, but something that we're taking note of as forecasters. Now you see these thunderstorms forming here across southern Illinois, southern Indiana later in the evening. But what is going to happen throughout the day is this cold front overtakes the dry line. I apologize if that's loud. Hood Base is located like a block from Midway Airport, so the airplanes and stuff are very loud. And it's warm out, so I've got the window open. Otherwise, I'd be sweating profusely. sitting up here. So I apologize if you hear some airplanes. But these storms that develop later, this cold front is going to be surging to the southeast, and it will overtake this dry line, so that by the time we get to well after sunset, the cold front will advance and overtake the dry line like this. And you can watch that happen on the dew point plot here. So let's just clear the whole screen. Imagine that that's where the dry line was. So you can see where the dry line is, this area here, right? This right here is the actual cold front, this little band of contours there. This is the actual cold front right there. And then here's our dry line. So just watch how this evolves as the event progresses. So this is 6 p.m., 5 p.m., 6 p.m., 7, 8, 9, 10, 11. And then you see by midnight that cold front catches up and overtakes that dry line. This is a pretty common evolution for these systems. So when we go back to the simulated reflectivity plot, you'll see that's when these storms are just starting to fire. That cold frontal forcing has now taken over and forced those storms up when we don't get them to develop much ahead of time in that dry line environment. So why? What is going on here that is causing this? Really the big thing here is, and hopefully we can pick this out a little bit easy. Let me see if I can zoom in. Let's zoom in a little bit closer. Let's go to our floater section here. Let's go to northern Illinois, and I may be able to see this a little bit closer. So let's go to. So this is about the time where that's going to be a factor. We're gonna leave this here on 0Z, so 6 p.m. tomorrow. This is your surface plot showing the temperatures here. So I'm going to trace everything again by looking at the dew points here. So just so we have an idea of where our frontal boundaries are. Here's your dry line, your cold front, back here like this, warm front. It's not most perfectly drawn warm front, but something like that. So warm front, cold front, and then you have your dry line in this region here. So we'll go back to our temperature plot, which has our wind vectors associated with it. So here's roughly the position of our frontal boundaries with our surface low developing, generally somewhere where those three meet, the triple point. That's a common thing here. And the reason for this is the dry line itself isn't necessarily favorably oriented. This is kind of a weird orientation for all of these surface patterns. Typically what happens is you have your low like this, your warm front comes out, your cold front back like this, and your dry line, tends to be a straight north and south oriented feature. So what typically happens is your winds blow counterclockwise around the low pressure like that, okay? So what that does is, let me erase some of this so it gets a little bit closer. So what that does is that backs the winds at the surface like this, because the wind flows counterclockwise around the center of your low. So typically you have backed southeasterly winds that allows moisture to pool ahead of that dry line. Well, in the case of tomorrow, we don't have that. The dry line is oriented in a weird way that it's kind of, it has almost too much of a bulge. And if we look at our surface winds, we've got strong southwesterly winds behind the dry line. But ahead of that dry line, we still have southerly and southwesterly winds here. There's not really good convergence along that dry line. So that is not going to help thunderstorms form here. We don't get backing winds up until we get the low pressure system up here. And they're not very strong because at this time of the day, the surface low is just starting to get going there. So surface winds are actually kind of weak in this environment here. They're only about 5 to 10 knots there. So very low, very slow winds in the low levels. That's not good for your wind shear. So we have a lack of overall forcing and convergence on this dry line. Not favorable for thunderstorm development. So that right there is potentially one reason. And then you'll see as we stair step a couple hours, that surface low really doesn't start to take shape, tighten up till well after dark, and we see those surface winds increase. So the timing of our cyclogenesis is perhaps just a little bit too late. This is a very progressive system there. We get the phasing a little bit late. So we don't have a lot of good convergence along that dry line here. So maybe that could be one reason why the models are failing to convect thunderstorms there. The other reason here, if we switch back to the dew point plot, and there we go. So you'll notice there's not a lot of really deep moisture along it. Our deepest moisture tongue is pooled a little bit further north, a little bit further south here. We don't see, the HRRR is mixing out some of those dew points just along and immediately ahead of the dry line. Because we don't have those southeasterly winds, we're not getting the moisture pooling along the dry line. See, this is what you want. You want your winds to be backed, blowing towards that dry line. That allows that moisture pooling. You get more instability, plus you get convergence there. That's what helps initiate storms. But instead, with tomorrow's setup, with these southwesterly, southerly winds kind of going like this, your overall shear vectors are parallel to your initiating boundary. That typically is not as favorable for storms. So where do the storms actually form? Right here on the cold front in north central Illinois, where the forcing is greater. They're being forced up by that cold front here. And we can see that if we switch back to the simulated reflectivity. See how our storms are just starting to fire right there along the cold front? We don't have that forcing here. Our winds are better backed. Strong northwesterly winds behind this cold front. Southeasterly winds ahead of that cold front. That cold front's going to force those thunderstorms up there. So we're seeing the trend in the models showing that we're not going to get thunderstorm initiation to perhaps after dark ahead of that cold front. So that is definitely something that we're going to be watching for in the evolution for tomorrow's event. And if this is indeed the case, that lowers the tornado threat quite substantially and turns large hail and damaging winds as the primary hazards for this event. So certainly an interesting trend worth noting. Now, just because this is what the latest model data shows doesn't necessarily mean coming into a little bit better position with the dry line, and maybe they'll hone in on a cluster of storms forming here or here. Instead, it took all of this out and only develops storms ahead of the cold front due to that strong forcing there. Another problem, and this has been kind of a bit of a strong cap in place tomorrow. So let's let the instability here load. If it'll load. Come on, internet, work with me. What do we got? All right, give me a second. We're gonna do this. I'm gonna put my hotspot on. All right, hopefully I am back. Let's see what we got here. Let's do this. Give me 1 second here, folks. I'm going to drop the bit rate because I can change that. So let's do this. All right, let's do that. All right, am I back? Let me know if I'm back. What's up, Nate? Good to see you here. We're back. Yeah, I switched Wi-Fi providers. I'm hotspotting off my phone here. I'm in the Chicago metro area, and I still can't get good Wi-Fi. Sheesh. It's probably because the router is downstairs and I'm upstairs, but nevertheless, apologize for that. Wouldn't be an Atom Live without some sort of poor Wi-Fi signal. Happens at Texas Base, happens here at Hood Base. I need to know the secret of how everybody else in the world seems to have stable internet but me. Doesn't matter where I'm at, what device I'm connected to, always something. So I believe we were talking about how potential capped environment here is another factor as to why we're holding off storms on the dry line here again. So this is the 0Z HRRR. keeping a pretty tight lid on things. We only see little holes here in the instability. So not much in the way of capping. And some of this low level, kind of wonkiness was sort of a concern that I've always had from the beginning here. And we're still seeing that capping inversion. I'm going to switch over to Pivotal here in a moment so we can look at some HRRR soundings. But there was always some concern for after dark and overnight, this being an overnight event due to some of the capping here. And that still looks like it indeed is the case. So let's jump over to Pivotal, look at our HRRR over here so we can get some lovely HRRR soundings. Yeah, I'm pretty sure Starlink is going to be in my future. I just need the $800 to $800 a month to pay for it. So let's look at let's go to the HRRR here. Look at the let's see, instability, severe weather. Let's look at our surface-based CAPE here. Give this a second to load. For those of you who enjoy my Atom versus Pivotal battles, we're about to have one. So here's our instability trends for tomorrow. And that's pretty good. That is a fair amount of instability here. To see instability modeled over 2,000 joules per kilogram of surface-based CAPE, that surface-based instability is not going to be a missing part of the equation tomorrow. One of the reasons we're still eyeing the potential for severe weather. The question is whether or not we're going to be able to tap into that instability. That has been a concern since day one here. Let's take a sounding from southwest Will County in Illinois here, somewhere around the Wilmington area. This was another primary concern of mine as well. There's a very tiny little hodograph there. Very small curvature in the low levels here. Because our surface low doesn't start really getting going until after dark here, we have a pretty low level wind shear in the lowest levels here. The overall bulk shear is pretty good for supercells. Look how long that hodograph is there. Fairly straight line too as well, suggesting that we'll have some splitting storms in the equation as well. But there's quite a bit of we have this sort of weak layer here between the 850 and 700 layer. And I think SPC even mentioned this yesterday in their outlook. Of course, our LCLs and LFCs aren't touching. That's always something that I look for here, but it's just the entire low to mid-level column isn't exactly primed here. We've got this little weak layer in the 850 to 700 millibar layer. Now, big instability can sometimes offset that with very steep lapse rates and very good vorticity. Sometimes that doesn't matter. But in the case tomorrow there where we have some little bit stronger capping here, and this is that capping showing up. It's just a very thin layer. So if we get a little bit more sunshine, heat things up a little bit more, we can perhaps achieve some surface-based instability, better surface-based thunderstorms. So in all likelihood, the signal for elevated supercells is actually stronger than surface-based supercells, where we have to erode through this layer right here. So our storm bases may be a little bit high. Pretend that's a thunderstorm there. So we might not even be realizing this part of the hodograph here. And when you have weaker low-level shear, this is a profile that favors very large hail more than tornadoes. So I think very large hail is actually going to be the primary threat there. And if you'll notice, most of our instability is elevated above that line. This is your instability line here, this dashed line, and most of it is above that layer there. We got a small amount of low-level instability, but it's this is the problem right there, from about 850 through about 750. A little bit of some capping there. So most of our instability is here, above our level free of convection, and it's a substantial amount of instability, especially when you consider it's still February. The freezing line's pretty low there, so you have a lot of instability above that freezing line there. So I think hail is going to be quite common with any supercells that we do get tomorrow. Now, of course, this is a sounding further south on the dry line environment here. You'll notice on this sounding, the convective temperature, which is right down here, is 78 degrees. On this particular HRRR sounding here, the temperature, it has the temperature at 70 degrees, which could be a little bit underdone, depending on the cloud cover that we have. Today, this area got into the low 70s, 71, 72, and with continued warm air advection, tomorrow should be warmer than today if we don't have a ton of cloud cover here. That is also another wild card, also another concern. But if we're allowed to have some sunshine and some clearing, we should be able to get warmer tomorrow than we were today. Then we'll get much closer to breaching these convective temperatures, and we would start our sounding somewhere over here, and it would remove this kind of stable low, we'll call it a stable area in the low levels there. So there's honestly a lot of things working against this setup for tomorrow in terms of getting a discrete supercell, at least on this model data. We need things to come together just a little bit differently. Again, just because this is what the latest model run shows doesn't mean that's exactly what's going to happen. The quality of moisture has always been a concern from the start, but let's go back to COD because it's faster. I'm curious. Let's go to the Southern Plains here and see what does the modeled moisture look at. We like to compare current observations to what the models have to say. So, pretty moist profile already. 60s dew points creeping into southern Missouri there. So, we look at the surface data, and do we have that? So, I know this plot is a little bit messy, but we do have 60s dew points here of northwest Tennessee, just getting into the southern tip of Illinois. We're looking for 60-degree dew points, and I'm tracing that line. So through Arkansas, northeast Texas. So the moisture is already streaming northward at a fairly good pace. So this is our 60-degree dew point contour. We've got 54 up here in central Illinois, Bloomington already. Dew points approaching in the mid-50s here, mid to upper 50s, southern Illinois. Southern Missouri. So the moisture is already on its way up. So I don't think we're going to have too much moisture issues tomorrow. Now that moisture might be shallow. That was the primary concern here. And you can see the HRRR looks like it resolved fairly well. The HRRR has a known bias where it tends to overmix things. So that is, that could be a potential fail mode in this model itself. We see this all the time with the HRRR and it's overmixing. So you see how here's the position of our dry line. This is 20Z, so 2 o'clock. You'll see these lower dew point values just ahead of the dry line there. This could be a model bias that the HRRR has. It likes to overmix these dew points here. Not all the models actually show this mixing. So that would be a potential fail mode for convective initiation. If the HRRR is overmixing the dew points, then of course it's going to struggle to initiate storms. Let's see what the NAM-NEST has by comparison. You'll see it's way different than the HRRR. It's also not as intense with the dryline bulge there. This is valid at the same time, so we're still getting dramatic differences in some of these models. In fact, the NAM-NEST here, it's not like the HRRR at all. We get 60s dew points well into central Illinois, just complete opposite of what the HRRR is showing. This is what makes forecasting such a nightmare. It barely even shows a dryline feature at all, to be honest with you. So whether or not this dryline feature becomes a factor tomorrow, I guess we're going to have to watch how the system evolves here. The NAM is pretty much just a cold front event. You might be able to pick out, some semblance of that weak dryline feature further west, but complete opposite of the HRRR. See, these are the two models valid for the same time. 0Z HRRR for 7 p.m. Wednesday, and then 0Z NAM-NEST for that's just total. Look at these different environments that these two models have to show here. What does the RAP have to say? The RAP closer in line with the HRRR. So the NAM is probably a toss solution here. This seems more believable to me, given what we're seeing evolve out west. We can look at some of our satellites here. Let's go to look at our water vapor. Where's the upper level? Maybe even, I think it's lower level water vapor we're going to want to look at here. You can see some of that dry air. Our system has barely even begun to take shape yet here. So even that is getting really hard to evolve. Here's our two pieces of the jet. They're still way out here. That's how fast the system is moving here. So, it's, we can barely even look at it on the water vapor satellite imagery right yet. So this is a very fast and quick evolving situation. Thank you, Nate, for the super chat. Thank you to everybody for tuning in. If you're new here, please consider hitting that subscribe button, that share button, get the word out. We're kind of just looking at the model data piece by piece. This is, we're taking a raw, sort of relaxed look here. So what does the RAP model have to show for convective initiation? It, too, does not fire anything on the dry line. In the dry line target area. Everything is north up along that warm front and ahead of the cold front there. You see the cold front lighting up as we get towards Wednesday morning there. Primarily linear mode, but not much to speak of. Looks like it tries to fire something here on the bulge right at 6 p.m. Little hints of convective initiation there on that bulge. Quickly merges, or maybe perhaps that's even with the warm front. Let's trace this. So the RAP fires a storm right here along I-55 in northeast Illinois. Where is it actually firing that storm? So kind of on that dry line bulge there. So you see it's also a little bit more, it's not as dramatically curved like the HRRR. It's a little bit more north to south orientation here, but still arced backwards like the HRRR. It does show some of that mixing of those dew points there, keeping the deep moisture further to the east. And that's because we have those southwesterly winds like we talked about in the beginning of the video. We need a deeper surface low located in this region here to keep those surface winds backed. So we see this moisture pooling along this dry line feature there. And that's what's going to help boost the instability. That's what's going to help increase the convergence along that dry line. That is the scenario that would get us a discrete supercell initiation across east central Illinois, west central Indiana, and those areas. But we're just not seeing it in the model data. Instead, we've got southwesterly winds behind the dry line and southwesterly southerly winds ahead of it. There's just no convergence there. That funnels all the deep moisture further off to the east, and that helps. What that also does is, because the more moist your air is, the more unstable it can become. That also helps keep the SIN, the convective inhibition, that cap in place, stronger. So when we go to our instability, that's why you see a stronger cap in place. See how it's all dashed? The cap is barely open here. That's why the lines are gridded and filled in like this. So, we lose that deeper moisture. The sun comes out, heats up that air in the low levels. That helps break. That's one way we can help break that cap. And we're just, there's just nothing really in place to help do that. It tries. Where you get a little bit of moisture pooling up here, you can see how it tries to break the cap there, where we get just a little bit more, a tongue of just a little bit deeper moisture coming in, because our winds start to back this up here. If you were to trace our surface winds, they're southwest, southerly, and then they do eventually start to back up into that warm front. So you get moisture pooling up here in this region here. So you can see the model trying to resolve that, and therefore it tries to break the cap in that region here, because we have at least a little bit. But the RAP does try to at least fire a storm there. Not a very strong bullish signal, but yeah. If these were the trends that were to verify, it's looking like tomorrow could almost be a cap bust in the warm sector for Illinois, Indiana, southern lower Michigan here. But still a threat along the warm front and the cold front here. But maybe we'll be pivoting more towards a hail and wind threat than a discrete supercell tornado threat. That's just what the 0Z data is showing here. And it's mainly going to be an after dark thing. Which, if you're a storm chaser like me, it's like, well, dang it, we got suckered again. But that's the way these things evolve. But we'll have to watch how it all comes together tomorrow and see if this is the actual environment that we see here. So just looks like a cluster of mainly elevated halers across northern Illinois tomorrow. We're seeing this on multiple models, but not much in the way of tornadic supercells anymore. Look at last night's 0Z HRRR. That was a wildly different solution than what we saw 24 hours ago. Discrete supercell convection ahead of that dryline bulge. Convergence was a little bit stronger. Moisture was a little bit deeper. And we saw discrete convection forming ahead of it as a result. Now, the one model that still seems to be holding on to that is the Euro. Now, we won't have the 0Z Euro in until like midnight, so I can't look at that right now. But even as recently as let's jump over to the Euro. Let's jump over to the Euro, the 18Z here. The Euro still holds a little bit more hope, I guess, so to say, for some of that prefrontal. Let's go to precipitation type and rate. And we'll look at some HRRR soundings in a moment here. I know I said I would do that. Thank you, Norsman. Any location time for a storm photographer to stage? I was thinking Rochelle. Well, if you're basing it off the 0Z data that we've been talking about, then yes, that would be the place to start. I'm not ready to write, so I'm still keeping my options open. I'm in Chicago, so I can go either way. But if you're basing it off the 0Z data, then yeah, it looks like we're only going to see cold frontal initiation. That's where the triple point will set up if it really looks like that dry line is not going to go tomorrow. And that sounds so weird to say in Illinois. Like, if the dry line isn't going to go tomorrow, that's not something I'm used to saying when it comes to Illinois setups. But I will be heading out that way as well, probably, because that looks like the only area that has a more guaranteed shot of seeing storms here. So this is the 18Z Euro, and it still shows some of that prefrontal or pre-dry line convection here. Again, it's a lower resolution model, but it still tries to fire discrete convection in that dry line environment. The Euro likes to not back down from its solution. So I'll be very curious to see what the 0Z Euro have to say. If the 0Z Euro lets go of this solution, then then I'd say it's pretty unanimous model consensus. But if we do get the storms to fire ahead of that dryline environment, it is an environment supportive of a supercell mode that is capable of producing at least a couple of tornadoes there. Fairly decent shaped photographs down here. If we're to draw our surface boundaries, there's that dry line. Warm front's going to be something like this. Cold front's going to be kind of like this with the surface low, something like that. So I'm thinking, based on some of the model data that we're seeing, is the dryline play is in question. Your higher confidence target, your better bet for storms is going to be, kind of where that warm front, cold front intersection is, sort of north central Illinois. And if we see storms fire further east, I think the warm front is going to end up being the play tomorrow, anywhere from northern Illinois into southern lower Michigan. So this area here appears to be the higher confidence target to get storms, probably only going to be a large hail, damaging wind type threat here. The dry line target, certainly a lot more conditional than it was looking a couple days ago. And it does appear like this initiation is going to be a little bit later. So maybe only a sunset and later type of events. There's just a lot going against this setup for it to really come together to be a significant event. But there are some things that do support the potential. Like, as a storm chaser and a weather nerd, I see both sides of it. I see the fail modes, and there are a lot of them for tomorrow, for none of these tornadic supercells to happen. But I also see how the case can be made where it's possible. So we kind of have to communicate both, and just the takeaway is, here's how it could work and here's how it can't work, and we just have to watch how it evolves tomorrow. So tomorrow very much is what we chasers call a wake up and see kind of day. I got to see how those surface observations are coming. If we get a little bit better backing winds, if we see more moisture pooling on that dry line tomorrow than what's being shown in these models, then the chance for the dry line target to go becomes up. The problem is I've got to pick a target by 1 o'clock. Sometimes these things don't come together right until the very last minute. So that especially when there's a major metro area like Chicago, I'm starting from right here. The problem is it takes me an hour and a half just to go here or here to get out of Chicago. So I have to make a decision earlier than normal. So that's the stinky part, in a situation like this. So I've got to commit by about 1 o'clock tomorrow, and then decide. So I'm going to be glued to the data all morning. What I'm going to be looking for tomorrow for this dry line target to go off is not quite such a candy cane number 7 look to it. If we see southwesterly winds and mixing out dew points ahead of this dry line, then it's probably not going to go. If it comes in a little bit better oriented, maybe something like this, kind of like what the NAM was trying to show, but which seems like it's an outlier solution, and we see a little bit better convergence along the dry line like this, with some dew points pooling along it, then the chance to see discrete supercell development ahead of it goes up. And I'll probably hedge my bets down there. We have to watch how this is exactly going to come together tomorrow. But the higher confidence target for storms does appear to be the warm front, cold front interaction here, somewhere up in north central Illinois, perhaps in the far southern lower Michigan there. So if I were to look at SPC's outlook, I keep saying I'm going to look at her soundings, I promise. I'll take a look here just a second. But if I were to look at SPC's outlooks here, kind of hone in on where I think some of this will come together. I do apologize if the internet's being wonky here. So, your higher confidence target to see storms is up in this area here, in my opinion. But those storms are more likely going to be hailers with lower tornadic potential. The lower confidence target is going to be somewhere in this region here, up into northern Indiana. But these would be the better chance to have a tornadic supercell. So it's kind of a, if you're a storm chaser like myself and you want to guarantee yourself a storm, pick the higher confidence target. But you're more likely just going to see hail, wind, and lightning. If you want to hedge your bets on a higher risk, high reward target for discrete supercells for tornadoes, then you're going to want to see storm development somewhere in this region here. So this is your lower confidence target. And this is your higher confidence target for hailers and wind. Your lower confidence tornado target is going to be further south on this one. And that's going to depend. I think for the most part, I wouldn't be surprised if we wake up tomorrow and, the slight risk if really I think this area here is kind of out of it. Everything we're seeing just has that dry line east of this area. So I won't be surprised if this area here, west of St. Louis, the western portion of Illinois, gets removed from the slight risk. I wouldn't be surprised if this risk kind of takes on a shape like this tomorrow. Chop away some of this western edge a little bit. That's just the way it seems to be evolving to me. And initiation right now does look pretty late, 5 to 8 p.m. Yeah, it is a cool map. Awesome map with all the photographs. I do like it. Making sure I didn't miss any super chats or anything like that. Thank you all for that. I really appreciate it. If you're new here, please consider subscribing, liking the channel. We do a lot of these detailed breakdowns. Typically, I can do something a little bit more in detail when there's not so much uncertainty. It's harder to do discussions when there's not a lot of confidence in the forecast. And this is a very low confidence forecast because these freaking models are just all over the place. So it's really hard to dial down timing and location. So we're just kind of covering here's the scenario that supports this. Here's the scenario that supports this. And unfortunately, I don't have very specific answers for very specific questions because this is just first off, it's a very weird surface pattern for this area. We don't typically deal with a setup that has a dry line and a cold front and a warm front like this. That's just not something we typically see around here. So, that right then and there tells us this is somewhat unusual. So we're going to be watching for how that evolves. Let's go back to the HRRR and look at a couple of soundings. Models. HRRR. What do I think about extreme southeastern Wisconsin? Right now, your chances of seeing storms are pretty good, but I think your main threat up there is going to be hail. You might just be north of that one front. Depends on how far north that one front gets. But right now, the case seems to be more towards elevated, more of an elevated hailer type of threat than like a surface-based tornado threat. Of course, Wisconsin saw their first February tornado a couple weeks ago from just the weirdest set of circumstances ever. So that just proves to us how wild and crazy weather can be. So let's go to our dew point and our wind barb plot here. Yeah, you know, I'll be happy with lightning. It's February. It's Illinois. It's Wisconsin. We take what we can get, right? If we're storm lovers. It's only February, right? Oh, this is the 3Z. We need the 0Z. So, of course, I'm going to be up all night looking at data, waiting for that 0Z Euro to come in right around midnight. I'll try to post an update on the Facebook page with some of my really late night thoughts here. So that is just so weird to see a dry line oriented like that. So this is 0Z. Let's take a sounding from this little bulge of moisture. Right on the dry line bulge here. Right on the dry line bulge. What do we see? If it will load. So that's better curvature in the low levels there. But, I mean, this is the big problem right here. Right there, that warm nose, that capping, that sin. You know, that's pretty cool at the surface there. Only 64 degrees with a convective temperature of 78. So you are not going to get a surface-based thunderstorm in that. If anything, you know, that's going to successfully keep a lid on things. Now, of course, this is after sunset, so the surface is cooling. We need to have a storm that's established and moving into this environment. Storms care a little bit less about convective inhibition, or sin as we call it. This isn't a lot of it. If you have already a mature supercell in this environment, it can battle that for a while, as long as the environment is continuing to destabilize and moisten. But we're not going to have a storm ongoing, so you're not going to fire a storm in this environment. You can sometimes maintain a storm in this environment, but you've got very good instability above that here. It's an impressive instability profile for February, especially in Illinois. So, you know, if we didn't have this issue, for all the reasons that we talked about, like, this is a pretty formidable environment for tornadic supercells, but you've got this kind of wonky stable layer there where, you know, it's just not going to allow that surface-based convection to really take off. Thank you, Burke, for the super chat. You know, and we're seeing that all across soundings in that environment there. So we don't have the strong frontal forcing to help force up a storm here. Again, look at your surface winds. And I think I can zoom in a little bit closer here. This is what I pay for Pivotal for. Yeah, let's do this. We'll zoom in on Illinois and Indiana. Make things a little bit easier for y'all to see, especially if you're watching me on a phone. So let's go to 0Z tomorrow. Let's do 6 p.m. Somewhere it's right here. It's pretty obvious where that dry line is, right? Your surface winds. They're southwesterly behind it, and they're southwesterly ahead of it. There's just no convergence. Even on the bulge, you know, you're starting to get some backing of the winds up here, because here's your surface low right here. So that's just not strong convergence, and you know, that's not going to help us force up a thunderstorm at all. This is what your wind field is doing here. So you don't have strong convergence there. And again, therefore you're not going to pool this deep moisture ahead of it there. So there's just a lot going wrong on this model data to suggest that those storms are going to happen tomorrow. We need it. We kind of need it to not evolve this way. We need a stronger surface low that phases a little bit earlier. The two troughs. If we were looking at the 500 millibar trough, you have the polar jet and the subtropical jet. They're supposed to phase, right? Well, that phasing happens a little bit too late tomorrow. If it were to happen a little bit earlier, we get a little bit deeper of a surface low here. We could potentially back these winds into that dry line. That would be a scenario that would support those thunderstorms. But we're just not seeing it in the data, so I have to believe that it's not going to happen. If I see it evolving exactly like this tomorrow, then, in my opinion, this target is off. At least in the daytime for surface-based supercells. When that cold front comes sweeping through, that's going to force up thunderstorms, just probably further east. And much of Illinois won't see thunderstorms in that scenario tomorrow. If we have to wait for the cold front to force up the thunderstorms tomorrow, then it's primarily going to be Indiana, southern lower Michigan, maybe far eastern Illinois after dark. So really, in order to get daytime thunderstorms tomorrow in Illinois, it's going to come down to the dry line firing them, and we're just not seeing that signal in the guidance, except for far northern Illinois, where your cold front is already up here and you've got that warm front draped something like this. So this cold front here will fire storms in this region here, and that's exactly what the models are showing. Thank you, Deborah, for the super chat. Y'all are super awesome to me. So we'll go back to the reflectivity. And again, that's why we see the only storm activity being fired here up in far northern Illinois. It's almost behind the surface low, like, it's almost post-frontal there, right there along that cold front there. So these will be elevated hailers. When I look at the 0Z data, I'm not seeing much of a tornado threat at all. This event will be a non-tornado producing event. If the 0Z data comes to fruition, this will not be a tornado producing event tomorrow, but primarily hail, wind, and lightning. So we're just going to have to pay attention and watch for it. Then, look at this. Snow on the backside. What? Record highs tomorrow in the Chicago area, followed by snow 12 hours later. Boy, that's fun. How about that? So, that's just what the data is showing. Justin, did I take a sounding near the triple point in northern Illinois already? I did not, but I can. So let's go do that. I'd be happy to. Let me get the dew point plot back here. I swear, the day COD implements this stuff, you will never see me use Pivotal again. They need to get their IT guys on it. Let's do around initiation time, 7 p.m. So your triple point is going to be, here's your cold front, right there. And of course, here's your dry line, like this. The warm front, actually I drew that wrong. Your cold front is like this. Here's your dry line. And then your warm front is kind of something like this. It may even be further north than that. The warm front could be further north than that, but for argument's sake, it's roughly about there. I'm looking for the wind shift. There's a little bit of a wind shift here south of Rockford, so we'll do right here. We'll do right here near Rochelle. I know that's where a couple folks were eyeing, so just south of Rochelle there. So this is near our triple point environment here. Again, we have that capping in the low levels there still. So still suggesting elevated supercell potential there. It's relatively small curvature, but still some curvature nonetheless. When you have low level wind shear, this isn't particularly strong. You only got about 5 knots at the surface, 10 knots to a low level jet of about 25 knots. So, you have sufficient, but kind of low level wind shear here. This does tend to also fail large hail. It's a good profile for supercells. Long hodograph, lots of bulk shear for supercells. So very supportive of supercells, but when there's just a little bit lacking down here, when you have good bulk shear but less low level wind shear, that tends to favor, it's very supportive of large hail. So I think hail is going to be the thing that we see most common tomorrow there. So let's see. Again, our convective temperature is 76. Surface temperature only 65. So we're relying on the cold front forcing to initiate those thunderstorms. These thunderstorms are not going to go up on the thermodynamic profile. So there's more than one ways to get a storm. They can go up thermodynamically from your instability, your sun heating, your cooling for ascent. Those are thermodynamics that help initiate thunderstorms. So, this is going to keep a lid on things throughout the day until that cold front arrives and just forces it up. But when it forces that up, it's going to be above your level free of convection here, or even your LCLs. At the LCLs. And that's above your surface layer here. So we're already above 850. This is going to be your storm base above 850. So, this just screams elevated supercell potential. Hey, Derek, thank you so much for that amazing super chat. Greatly appreciated. So, this screams elevated supercell potential, at least initially, probably transitioning to linear modes due to that cold frontal forcing. But I'm telling you, this is a really good sounding. If you like hail, if you want to get out and play in some hail, then this is for it. You've got this is a very good instability profile for Illinois for this time of year, but it's all up there. There's nothing favorable at the surface here, so it's just not looking good for surface-based supercells capable of producing tornadoes. You need a really strong, really mature, really isolated supercell to hopefully, I think Reed Timmer uses this term. He says drilling down. In rare cases, if you have a discrete, mature, strong enough supercell and you have good vorticity and a really strong updraft, just constantly feeding it, very good surface vorticity, sometimes it can do what's called drill down or dynamic piping, I think the term is. And sometimes it can compensate and drill through that stable layer. It doesn't happen a lot, but there have been cases where this does happen. It's just not very common. But weather likes to break its own rules sometimes. Sort of an unusual way to get it to happen, but it does happen. It's not something I'd bet on. It's kind of an, crap, it happens when I didn't expect it. It's not something I'd ever bet on, but it does happen. Amir is asking, can I show a sounding in southern Wisconsin? Absolutely. So I'm going to have to back up here. Let's go back to a Midwest view. I imagine it'll look pretty much the same. But I'd be happy to look at one real quick. So right here, so for southern Wisconsin at 0Z, there's not much of the state that's going to be unstable. So it's going to be a very capped, stable sound. We'll do extreme southeastern Wisconsin, kind of in the Milwaukee area. It's really the only area that's going to have any shot at having any instability, because this is all behind the cold front. So I think much of Wisconsin is going to be out of the risk tomorrow, except for perhaps far southeast Wisconsin here. So we'll take one from around the Milwaukee area, just because, again, that's really the only part of the state that has any shot at being unstable, just because of the fast timing of this. Even throughout the day, you have a little bit. I know this isn't the instability plot, but your instability generally lines up with your moisture. So we'll take one from around the Milwaukee area at 7 p.m. See what we have to say. Oh, wow, Nate, you can hear that? That is one of my favorite sounds in the entire world. So where Hood Base is, the southwest side of Chicago, the Belt train yard is literally like 2 blocks. And this is what it's called. It's called the humping bridge. So essentially what they do is the train yards, they push boxcars over this bridge. And then they're basically runaway boxcars going down a bridge, and then they slam into each other. That's how they hook up the trains together. That screeching sound you hear is the tracks squeezing the wheels to try to slow them down. So, of course, they don't pick up too much speed. It's called the humping bridge. So that's the screeching sound that you hear in the background. I love that sound. I grew up with it. It's like an ambient, soothing sound for me. I miss it when I'm in Texas. Even Chelsea has grown to love that sound. I'll turn down my fan and you'll be able to hear it better. I'm surprised you can hear that. Jen says St. Jane. Yeah, you're not far. I was St. Symphorosa. St. Symphorosa. So here's our sounding from extreme southeast Wisconsin. Again, pretty similar. All your instability is elevated. Here's your level free of convection. All your instability is above that. So, again, this screams elevated thunderstorms if you get any at all. The hodograph is even smaller up here, probably right along or just north of that one front here. You even got some veer going here. So this is a very messy signature. Elevated hailers are about all you're going to get out of this. So a very poor environment for tornadoes if that's what you're looking for. Let's see what else we got. Some decent 3-cape. It's just not going to be realized. But a little bit of veering in the profile there. So, yeah, this is definitely not really a tornadic environment. But, anytime you have, when you're looking at soundings, anytime you have a long hodograph, that's good, what we call bulk shear. That is favorable for, that can support organized thunderstorms, supercells, embedded supercells. In the case of tomorrow, with a strong linear forcing, can be organized squall lines, bow echoes, that type of thing. So anytime you have good bulk shear, that does support organized thunderstorms. So it has that. The turning in the low levels is very, very limited. So not overall a good environment for sustained supercells, maybe transient supercell modes, but your instability is all elevated. Your LFC and your LCL are very high up. Your LCL being the lifted condensation level. That's what LCL stands for, this number here. And you can see it's above the 850 layer. So, your 850 millibars being about, 1,500 feet, 1,500 feet. I forget what it is exactly, but it's basically higher than 1,000 feet. That's when we start considering the mid-levels. That's still the low levels. My bad. Mid-levels are further up. But, generally for tornadic supercells, you want that LCL to be below the 850 level. So it's just they're going to be a little bit too high. Your level free of convection is even higher than that. So not necessarily the best looking tornadic sounding. Would the sounding in Racine be any different than Milwaukee? Probably not by much. Can I jump down on this? They may even be so close that the grid points aren't far enough, but it'll generally be the same unless the environment itself drastically changes, which tomorrow it's pretty similar. Milwaukee being over here, Racine being here. It's pretty much the same environment. So in this case, no, they won't. Now, if Milwaukee was here and Racine was here, there'd be a big difference from being in front of the front versus behind it. But on this particular plot, for the sake of severe weather hours tomorrow, they'll be actually pretty similar. You went to school with my brother? You went to school with Tony. How about that? He's in Kentucky. He's in Kentucky now. It's a small world. I'll tell him you said hi. I may be visiting them. He moved to Kentucky. I may be visiting him in a couple of weeks. Amir, can I check the reflectivity in southern Wisconsin? Sure. Let me go back to COD for that because it's faster. And I love my COD scroller. So this is using the 0Z HRRR. Again, doesn't mean that this is the end-all, be-all, but here's what it's showing. Am I too far ahead? Oh, geez, it's on yesterday's. So here's the recent run. So it kind of clips, far southeastern Wisconsin with, it's just some embedded. We see some helicity streaks here due to that bulk shear. So you'll see the model spits out helicity streaks. We like to look for the helicity streaks, right? That is a result of that bulk shear that we see in the sounding. So even though it's kind of a messy linear cluster, still going to be capable of producing severe weather because we have the overall bulk shear to support organized convection. Even if it's linear, just because it's linear doesn't mean we're not going to see severe weather. And we can look at that and go at our, we can look at our updraft helicity streaks. We like those, right? That tells us where the tornadoes will be, right? Updraft helicity swaths there. So you see we still get them. You still get those embedded areas of rotation within that line. But they are going to be linear, messier storm modes there with lower bulk, with weaker, lower level wind shear. So I think the primary threat is going to be that large hail in this region. So this is the higher confidence area to see storms, roughly from like I-88 in north, from Illinois to far southeastern Wisconsin, but they're going to be hailers. Any storm that stands a better chance at being tornadic is going to be earlier in the day down in this region here. So as a storm chaser, do I take the high risk, high reward, or do I guarantee myself for storms and chase over here? I'm going to have to make that decision tomorrow based on how this evolves. So, hopefully we understand the ways that it can happen, the reasons that it could happen, and then it makes sense if nothing happens. If the way the HRRR, if this solution verifies, then most of that slight risk is going to bust. There's not going to be much storm activity in it at all. That's why it's a slight risk. That's why it's not enhanced. That's why it's not moderate, because this is a very low confidence, kind of wonky situation where it's like, yes, there are cases to be made for the storms to be possible, but there's a lot going against it, especially with tonight's latest trends here. It was looking more bullish like 24 hours ago. That's for sure. If we compare this to yesterday's, it's quite the difference. Southern Wisconsin and that part of Illinois wasn't even in play. This is how much, these dang models shift around with this information, and why we're always encouraging y'all to seek out the latest information. It's not because we're lying or wrong or just making stuff up. It's what the data shows. This was yesterday and this is today. Completely different scenarios because, the models tend to, the system comes on shore, they get more real-time data ingested into it. Typically, the more recent model runs are more reliable, but not always. Those Tennessee tornadoes that happened back in December, that day looked like garbage going into it, but the day evolved a little bit more favorably. Suddenly by 1 o'clock, I was going, this is going to be a big problem for Tennessee because it came together different than what the models were showing. What happened on that day in Tennessee is, you had your risk area. There was a little area of convergence that the models didn't pick up on. So we had a subtle area of convergence that the models didn't pick up on that day. And that's where all the tornadoes, the tornadic supercells happened. They developed out here, they moved up, and they all produced in that same area where we had a little bit more backed winds than all the forecast models showed. And that's why that Tennessee day overperformed back in December. Could something like that happen tomorrow? Yes. We're just not seeing it in the data today, and it's probably a lower probability scenario. But nevertheless, that would be how tomorrow gets it done. Does anybody have any other questions? I'd be happy to answer them. Hey, Siege. Good to see you here. Or Siege. Did I say that wrong? Deborah, are you still in Adam's Facebook supporter group? Good setup location there. Yeah, I did post in my Facebook supporter group a couple. I posted the 2 different targets and what to consider for tomorrow. That was based off the 12Z, this morning's model data. 0Z data completely changed the forecast. That's for dang sure. Now, as for those of you who follow me on Facebook, you're in my supporter group, the model watch parties and things like that. I will not be doing any lives on Facebook until at least April 10th, because January 10th that was the second false violation I've got. For those of you who don't know, I used to be doing this a lot on Facebook, but they've been kind of screwing me over lately with these false violations for nudity, adult content. Spoiler alert, there is none. It's not that kind of model watch party. But anyways, I got hit with two. If I get another one within 90 days, then I get a 3-month ban. So since that second false infraction occurred on January 10th, I'm not touching a Facebook Live until April 10th. Then my profile will reset and everything should all be good. But just I can't risk it. So I know that's a bummer. Trust me, nobody's more upset about that than me. It's a huge blow to everything I've been building for the last couple of years. You guys have been amazing for supporting me in that. So it's a huge blow to me. It's costing me a lot of money. But that's just the reality of the situation is I can't risk it because if I get a ban for 3 months, no monetization, like that is absolutely crippling for my income. I'd be one of those storm chasers that would be begging y'all for money all the time. And I'm just not that type of person. Like I don't expect anybody to pay for my way, even though the donations, everything it is what helps keep me out there. I just don't like to beg for it. I want you guys to find value in what I'm doing and choose to support me. I don't want to be one of these guys that's like, donate to my GoFundMe. I need to be out there to save lives. Like that's just not me. Okay. If you guys find value in what I'm doing, then yes, I do appreciate, and will always accept this support. But I want you guys to find it useful, and I want to cater my content to what y'all want. But that's just the reality of my situation. I can't risk getting another false infraction. So I will not be doing any Facebook Lives until April 10th at the very least. Unless Facebook somehow emails me and says, hey, we're sorry. We realized, like, we fixed it, blah, blah, blah. But I don't count on that happening. I must have had 30 or 40 emails with them back and forth. Just, you get nowhere with them. Absolutely worthless. Yeah, it could be, could be the bear. That's been what some of the people have suggested. Like, is it because I'm wearing, but I really don't want to believe that it's that, but you never know. I guess it could. That'd be really stupid, right? Because if this is what Facebook considers adult content, there are way worse things showing up on the site that don't get removed. That's what the most frustrating part about it is seeing this other way more rambunctious stuff survive. And then this apparently is what crosses the line. Come on. So where do I think the worst of it is going to be tomorrow? Right now, based on the 0Z guidance here, it's going to be far northern Illinois, north of the I-88 corridor. Perhaps some intense linear storms, far southern Indiana, along the Ohio River there. It's a big old bust in this region here. But that's just based off the 0Z data. We'll see what the 12Z data has to say. We'll see how the system evolves. As far as the timing of this goes, it's going to be between 5 and 8 p.m. for northern Illinois, probably after 8 p.m. for southern lower Michigan, and anything for northern Indiana. If you're in this portion of Illinois and you don't have a thunderstorm by 7 p.m., then, that's probably it. It's probably over. Your window for storms in this part of the state is like 4 to 7 p.m. From here on out, it's, 7 to 10 p.m. for over here, and so on and so forth there. So I won't be surprised if much of Illinois doesn't see anything tomorrow. I know, Ashley, it's incredibly frustrating. Tanner, how are you reacting to the tornadoes and severe weather then? That same night having snow come through. Well, it is February. I'm a weather nerd, first and foremost. I love extreme weather. I love the fast. To me, I think it's awesome. It's like, oh my gosh, I'm looking at a thunderstorm and then 6 hours later there's snow. I think it's cool. I know not everybody shares that opinion. Now, it's not cool in May because I'm over snow by that point. But in February, that's pretty cool. Oh, I know. I see the stuff too, and they don't remove it. It's very frustrating. Very, very frustrating. And it's not even that I myself have a problem with that stuff. Like, I really don't care. If I don't want to see it, I'll just ignore it. And that's what I do. But just the fact that when I get an infraction and they give me this, oh, we're trying to keep the community safe, blah, blah, blah. They give me all that BS, and then they don't remove the actual stuff. It's just hypocritical. That's the part that upsets me the most. Like don't feed me this community safety nonsense. If you're not actually going to remove the harmful content, but you're going to strike me under it, yeah. I'm going off on a tangent here. Sherry, curious. We're on the Indiana-Illinois border, so I don't know quite how bad to expect since it's getting really hyped up. Yeah, I will say that the zero-Z models downtrended your area quite a bit here, so there's a lot of uncertainty for your portion here. If we're to look at the risk area, I'll pull this up again. There's kind of two scenarios at play. I do love these little zoom things that Pivotal has. You can zoom in on the convective outlook here. This is very nice. It's very nice. So the way the risk area kind of dices down tomorrow is this is the area that's probably most likely to see storms, but they're going to be hailers. You have a lower tornado threat up here. This is the area that's less likely to see storms, but if they do occur, you have a greater tornado threat down here if you get a storm. But to get thunderstorms down here is going to be tougher. So it's kind of a catch-22. The area most likely to see storms, they won't be as bad. There'll be hail, there'll be wind, there'll be lightning. Some of the hail could be golf ball size or bigger. So I shouldn't say it won't be bad. It won't be bad in terms of tornadoes there. So that's kind of the way that this all kind of slices and dices here. Is your lower confidence target has a better chance of seeing a tornado than your higher confidence target, if that makes sense. That's the way this is kind of evolving, the way it's shaping out. Nate's it's too late, Nate. I already got started. Thank you, Sherry. I appreciate the recommendation. I try to keep it real. I'm not always right. I can only interject my thoughts based on the data that I see. And sometimes that data is very confusing, like it is tomorrow. I was really shocked to see the zero-Z models come in the way that they came in. One more thing I'm kind of curious here is what's the quality of the moisture? I need to see an observed sounding here. Let's check this out. I only tell the Facebook story so much because I know there's a lot of new folks that hopefully tune into these, and not everybody checks their Facebook every day. So some people may still not know about the situation. Some people only go on every so often, and then they go, "Oh man, this guy hasn't said anything in a while. Why is that?" Forecast tools. I want to look at an observed sounding real quick and see. So OUN, what is our moisture? It's a little shallow. It's not super shallow. So I think we're going to see, I won't be surprised if moisture overperforms tomorrow. But we'll have to see if any of that mixes out. The moisture is a little shallow. What I mean when I talk about shallow moisture is what the quality of moisture is. Shallow moisture would be as if this green line went like this. That would be truly shallow moisture here. It's not super deep, but it's also not shallow. A nice moist column here. We're talking about something that would be like this, right? You can see that the evidence of that elevated mixed layer, though. That can be so crucial sometimes to helping get discrete convection. So definite presence of an EML, your temperatures rise where your moisture drops off. That's your EML. That's the elevated mixed layer. That's the cap. But check out the hodograph. That's the environment that's coming north. That's pretty decent curvature there in this hodograph here. Favored for southeast movers, but that's not what we're going to have tomorrow. That'll straighten out a little bit. This will come up. Once we get that low level jet response here. This is a very late timed system where everything comes together kind of last minute. But it supports severe weather. I heard a lot of folks talking about really shallow moisture, so I was expecting to see something like this. So it's actually a little bit deeper than I would have guessed. Based on all of these really shallow moisture fears, it's not that terrible. Boy, that's a really stout capping inversion here. Where did I pull this from? Come on, scroll up, will you? Lake Charles. That's a very steep, very stout capping inversion there. Yeah, right, Shane. The moisture isn't as bad as I would have thought. There's been a lot of talk like, oh, the moisture's not going to make it. It's going to be real shallow. It's going to mix out easily, but I certainly wouldn't call it deep. But I don't know if I'd call that shallow when it's almost up to 850. We do need moisture a little bit higher than that, but it's not bad. And it's going to be pumping up all night, so we'll see. Let's see. But that's about all I've got for the analytics for the data. Again, I apologize for if anyone was looking for something a little bit more specific with timing and threats, but when the data is not showing storms and it's a very low confidence scenario, we just have to kind of pick apart and go over some hypothetical situations that could get our storms to form here. So that's kind of what this discussion more along the lines was. This was more hypothetical scenarios than what we're actually seeing. What we're actually seeing in the data is a great reduction in the severe threat in this area here. Like there's like nothing. That's what the data is showing. So, but we talked about a scenario that could evolve, that could make it happen. It's a low probability, but I'll be posting the updates where it's like, hey, this is starting to trend up. It's starting to trend a little better. So just watch for those updates on Facebook, on Twitter, and that sort of thing. I'll be live streaming here on YouTube. I am going to go out and chase regardless. I'll make a decision whether or not I'm going to take the higher risk play or just go, drive around in some hail up here. I'll make that decision by 1 o'clock tomorrow, probably. Either way, I'll be streaming here on YouTube. I'll be providing all the forecast updates on Facebook as necessary. You guys hopefully know where to find me. If you're new here, please hit the like, share button. I appreciate the subscribers. All you guys who sent super chats, guys and gals, thank you so much. Definitely helps keep the gas in the tank, helps keep the chase going. Makes me feel like I'm doing something right, so I appreciate that. The NAM shows storms firing across northern Illinois around 4Z. Yep, sure does. So that's, we're trending towards more of an after dark hailer threat for tomorrow. And that's kind of the too long, don't watch version of the video is, daytime supercell tornado potential going down in this region here. After dark hailer potential going up in this region here. Kind of the too long, don't watch version of the video. So I appreciate y'all hanging out with me for this hour and hour and 20 minutes now. Yeah, I feel bad for Steven. If he drives up and it plays out this way, that stinks. If I was in Texas, I'd really be struggling with the decision to come up here. That's a long drive for some elevated hailers. But since I'm here at Hood Base, it's a no-brainer. I'll be out there chasing. So thank you all once again. Stay tuned for more updates. I'll be live here on YouTube tomorrow for the chase. Follow me on Facebook, Twitter, those things for forecast updates throughout the day. And I appreciate y'all so much. Again, give it a like, give it a follow. That is a free way to support the channel and help it grow. For all you guys and gals who sent super chats, you guys are legends. You guys are awesome. Appreciate y'all so much. So enjoy the rest of your night. I will catch y'all on the next one.